On to problem number 7 of the MIT integration big qualifying exam 2016, which is a definite integral from x equals negative 27 to x equals to positive 27 of the arc sine of x to the power 1/3 over 3. So we're going to see two different solutions, the short version and the long version. And I mean, typically, I think if you're trying to solve this problem, you'd probably use a shorter version to be able to, efficiently use your time. So let's see how we may be able to solve this problem. Integral from x equals to negative 27 to positive 27 of the arc sine of x to the power 1/3 over 3, right? You may be able to write it as something like this, right? X to the power 1/3 over 3. So let's say our function fx is equals to arc sine of x to the power 1/3 over 3. And we have an arbitrary number, real positive number p. This is an arbitrary positive number. So f of p will be equal to arc sine of p over 3, right? However, if you have f of negative p, you would have negative, which is equals to negative of f of p. So, I mean, this is all really not needed, but what we are learning here is that every positive number in the x domain has a corresponding number in the negative domain of equal magnitude in the negative domain that gives the same image or fp but of negative sign. So just a representation that might help us is if you probably had something like that. I'm not saying this is how it would look like. In the negative domain, things would look like that. So that the area in the positive domain is positive, and then in the negative domain it's going to be negative. So essentially what you're having is that since we're having equal extent in the negative domain as in the positive domain, so the integral is just equal to 0 because this area in the positive is going to cancel out with the negative area in the negative domain, right? This is just an illustration. It doesn't depict what is the actual plot of the arc sine of x to the power 1/3 over 3. So that's the short and quick form. However, we may as well, so this is the long method. If you say let u be equal to the arc sine of x to the power 1/3 over 3, then sine of u is equal to x to the power 1/3 over 3. In other words, 3 sine u is equal to x over 1/3 which means that 27 sine cube u is equals to x. And since 27 sine cube u is equals to x, what this means is that 81 sine squared u cosine u du dx is equals to 1. So we can substitute dx with 81 sine squared cosine u du. Now we have to look at the limits. Since we've said that u is equals to arc sine of x cube root over 3, then it means that in the x domain you have negative 27 as the lower limit and a positive 27 upper limit. So the cube root of negative 27 is negative 3, divided by 3 is negative 1, and so the arc sine of that is negative pi over 2. And so in the positive domain we have positive pi over 2. Therefore, negative 27 to positive 27 of the arc sine of x the third of the power third over 3 dx is equals to negative pi over 2 of pi over 2, and this part here becomes u, dx becomes 81 sine squared cosine u. So this becomes 81 over 2 to pi over 2 as u sine squared cosine u du. Okay, so sine squared u cosine u is equals to a half sine u to sine u cosine u. This part becomes sine 2u. This becomes a half sine u sine 2u. Then if you have cosine u plus 2u, you get cosine u cosine 2u minus sine u sine 2u cosine 2u minus u is equals to cosine u cosine 2u plus sine u sine 2u. So that when you add this, you get cosine 3u plus cosine u is equals to twice sine u plus sine 2u. Therefore, sine u sine 2u is equals to a half of cosine 3u plus cosine u. So using this relationship, and particularly this last part here, we can now say that our 81 over 2 negative pi over 2 pi over 2 of sine u sine 2u u is the same as 81 over 4 negative pi over 2 pi over 2. There's a u here, sorry. So u in bracket cosine 3u plus cosine u. Okay. So this becomes 81 over 4 pi over 2 pi over 2 cosine u cosine 3u plus u cosine u. Okay. And then we can express this as u du a third sine 3u plus u sine u. So using integration by parts, this becomes u over 3 sine 3u negative pi over 2 plus u sine u negative pi over 2 minus a third sine 3u minus sine u du. And so one may ask, why did we have, so I consider this as two separate integrals, this and this, and then I use integration by parts, and let me use a different color to denote that. Integration by part tells us that if you're integrating a product v and a derivative of function capital U, you get uv minus the integral of the product of capital U and the derivative of function v, like that. And so here du was, in this instance, this was u, and in this instance, this was u. And that's why we had uv here and uv here for the second integral. And then now, when you differentiate u with respect to u, the u disappears, and we are left with, we differentiate v, which is u and u, it goes to 1, and now we are left with the capital U, which is a third sine u and sine u down here. So we have u over 3 sine 3u negative pi over 2 to pi over 2 plus u sine u negative pi over 2 minus a third sine 3u negative pi over 2 u minus sine u over 2 pi over 2. So this becomes pi over 2 divided by 3 is pi over 6, sorry, sine 3 pi over 2 minus negative pi over 6, and then sine negative 3 pi over 2. Essentially, this negative comes out here, and it becomes positive, and then this cancel out, becomes 0, plus the same thing happens for this part where we have pi over 2 sine pi over 2 minus negative pi over 2 sine negative pi over 2. This comes here and this becomes positive, and essentially this and this cancel out. And so we are left with now plus, when you integrate sine 3u, it becomes negative cosine 3u over 3, so this becomes 1 over 9 cosine 3 u negative pi over 2 negative pi over 2 plus cosine u negative pi over 2 negative pi over 2. Again, cosine 3 pi over 2 is 0, cosine of negative 3 pi over 2 is 0, so this entire thing goes to 0 as well. The same thing here goes to 0. Cosine pi over 2 is 0, cosine negative pi over 2 is 0. So this entire thing boils down to 0, and we can authoritatively say that integrating from negative 27 to positive 27 of the arcsine of x over to the power third over 3 is equal to 0. So, and that is our answer.